Okay, next presenting for Chilldyne is Bob Spears, who is president and CEO of a company that already has $2 million plus customers of its patented liquid cooling system. Chilldyne's solution actually helps data centers reduce HVAC costs, increase server density, and cool the newest, most powerful chips that can't be air-cooled. So Bob, all yours.
Hi, good morning. I'm pleased to be here today. At Chilldyne, we patented a way to safely liquid cool a data center, yielding significant financial and operational gains. We've had $2 million of sales to one reseller in Korea, and we just made another $1 million sale in the United States. The difference is our system pumps water through a system with negative pressure instead of positive pressure, which is what all the competitive technologies on the market are doing. And we got into this business when my CTO partner, Steve Harrington, who's in Albuquerque today getting ready to install this new system, was told that half the electricity used in a data center goes to air-conditioned servers that don't sweat. And we can go through that, there we go. Data center cooling is becoming a problem because server chips keep getting hotter and hotter. Intel Xeon chip is up tenfold in power from when it was first introduced 30 years ago. Moreover, the move to artificial intelligence, virtual reality computing means you now have multiple of these powerful chips in a single chassis. For example, we just designed a system for our hardware partner, Penguin, that has 4,000 watts in a single 1.75-inch server. If you had a whole 62U rack of this, you'd have 240,000 watts or 240 kilowatts of power in a single footprint. You can only cool typically 5 to 10 kilowatts with air, so you cannot cool that system with air cooling. Cooling is also more difficult and expensive as people have gotten into edge data centers that they're putting closer to the users. They started with all these Pacific Northwest, very efficient, cold environments, but if all the data centers were where it's cold, then it'd be too long a latency for where the users are, for example, in Texas and Florida. So they're now building data centers in hotter, more expensive locations. That's hard for air to cool. Data centers now use 3% of the world's electricity, and they're on their way to 10% by the end of the next decade. Industry experts think that more and more of the cooling will move from air to liquid, and it'll take liquid cooling up 3x to 3 billion a year in the next few years. The chief barrier to this growth is the customer fear of leaks, which would bring damage and downtime, and that's the impediment to the growth, and we have solved that leak problem. We've had $2 million in repeat sales to a single reseller in South Korea that sold and installed our system in 2 South Korean national labs. More importantly, just this week, we're installing a system in the new Penguin's new supercomputer cluster at the DOE's Sandia National Lab. It's a lot of to put together. Suffice it to say, for us, it's a really big deal. This is finally a U.S. customer reference site we can take prospective customers to show them the system, provided it works the way we think and believe it will, and that judgment starts tomorrow. U.S. data centers spend $7 billion a year on electricity for cooling. We lower cooling costs by 1/3, which is worth $2 billion plus a year in the U.S. and double that globally. But getting back to the fear though, when you tell a data center operator we're going to put water in your server, they have a simple response. They say, oh no, you're not. So we do show them. This is an example of a really bad leak. We do a cut the line demo. If this was done with a typical positive pressure system that our competitors sell, you'd now have water spraying all over the data center. It's like sticking a knife in a garden hose. But since we're using negative pressure, the leak meant the water was pulled away in both directions from the leak, and the fans go back up to full power to give you backup air cooling while you figure out what you just did wrong to lose the cooling loop. What we did is we designed and patented a whole ecosystem around this negative pressure, and that pumps water through the data center and then rejects the heat outdoors into whatever sort of a cooling loop you want to use. Our latest project cools 1,500 Penguin dual Intel server chips. We converted their server to liquid cooling by making a hybrid air-liquid heat sink and then having a supplier make the heat sinks, put some tubes on it, send the cooling kit to Penguin. Penguin installed it on their assembly line. They like our system because they can boot up the server in air-cooled mode, which they could not do with the previous liquid cooling partner they had before us. We designed our system to be easy to set up and operate and to have zero downtime, which again addresses all the fears of liquid cooling. Our premise is that you can reduce air conditioning by 75% and pay for our system with this capital and OpEx savings. Eliminating air conditioning saves money, power, water, and yields a quick ROI. We're seeking $1.5 million to fund sales efforts to capitalize on our recent sale to Penguin. With Penguin, we're going to be at the Supercomputer Show in Denver in November, showing the system off. We have a BD expert working with us to introduce us to companies to be a supply chain partner, a sales partner where they're already selling other non-competitive products to data centers, a customer partner that needs to convert an existing high-power electrical device that's air-cooled to be liquid-cooled. Think telco switches, enterprise-scale routers, that sort of thing. Data centers all see a big power problem loom, but they don't know how to address the problem. Our primary competitors took gamer systems that do one server at a time and upscaled it to the data center. A gamer system has no connections to speak of, but if you sell a system to cool 1,000 data center servers, that system's going to have tens of thousands of liquid connections. If any one of them leak, game over. We are solving this problem because Chilldyne and our sister company, Flowmetrics, has experience with high-performance electric aerospace systems and also low-cost disposable medical devices. And that's what made this unique solution possible. Thank you.